Children, now let us start with the second question that it was given statement 1 and 2. We have to understand this and we have to say which statement is right or wrong. So, the first statement was given that an elevator can go up or down with a uniform speed. So, he is speaking about what? Now, let me ask you, this is from which particular chapter? No doubt it is from laws of motion. No doubt it is from normal reaction concept. Okay. So, whenever we say that uniform motion, what happens is that here, whenever there is a uniform speed or uniform motion, the acceleration is equal to 0. In the second case, what is happening is that, so the elevator goes up or down with increasing speed. That we have to highlight this. Elevator goes up or down with increasing speed. So, these are the two things which we have to remember. Okay. So, what he is asking is that, choose the correct statement. So, now look at the first question. An elevator can go up or down with uniform speed when its weight is balanced with the tension of its cable. So, weight must be equal to tension of its cable. So, now what happens? Okay. So, what I say is that normal reaction N, okay, when the weight is balanced. So, on this also I have to underline this, right? Statement 1. Weight is balanced. Weight is here balanced. So, what does it mean? Let me say this is elevator subjected to tensional force and this downward force is mg, which we call it as weight. So, here what is happening is that when elevator is moving with uniform speed, what is happening? Weight is said to be balanced. Okay, let us see that. Uniform speed. It means the acceleration is equal to 0. So, what is the equation now? Upward force must be equal to the downward force. So, this is what is sum of the force along y-axis is equal to 0. Upward is tension and downward is mg. Or you can say weight. So, tension equal to weight. So, mg stands for weight. Okay. So, now it was very clear that the first statement is correct. First statement is correct. Okay, right, good. Now, let us go with the statement 2. Statement 2. So, this is statement 1. So, coming to statement 2, what is happening is that force exerted on the floor of an elevator, okay, on the person standing on his will be more. So, this we have to underline. More. So, let us check. More than his weight. So, when it goes down, right, when it goes down. So, this is our elevator, right, body of mass, mg, upward is tension. So, elevator is going down. So, this is the direction of acceleration. So, this direction of acceleration is in downward direction, which clearly indicates that downward force is greater than upward force. Which clearly indicates that downward force is greater than upward force. Okay. So, because of this direction of acceleration, what I mean to say is that downward force here it is weight. Okay. So, weight is greater than upward force. The equation is now downward force minus upward force is equal to mass into acceleration. Mass into acceleration. So, mg minus t is equal to ma. So, t equal to mg minus ma. So, mg is the actual weight. But in the given question, what he is saying is that when the elevator goes down, okay, then what he is saying is that it must be more than its weight. But it's not so, because here mg minus ma is there, it is decreasing. So, statement 2 is false. So, the correct option for this one is statement 1 is true and statement 2 is false. Okay, children. So, with this, I am closing the second objective question. We will move on to the next one.